two disks of same moment of inertia rotating about their regular axis passing through the center and perpendicular to the plane of the disk with the angular velocity omega 1 and omega 2. They are brought in contact face to face coinciding the axis of rotation. Now we have to find what will be the loss of energy during this process. So this is let's say disk 1, it has moment of inertia I and it is rotating with the angular velocity of omega 1. Now coinciding with this, let's say this is our axis of rotation, we are given other disk and the other disk also has moment of inertia I, but it is rotating with a velocity of omega 1. Now this disk, both are placed on each other, this disk has brought in contact with the other disk. Now what we are given that this is let's say smaller disk and now this is the larger disk and both are rotating together, and let's say now they are moving with the angular velocity of omega, and their now moment of inertia will be I plus I, that will be equal to 2I. Here all the forces which will work will be the internal forces, and we can say that the angular momentum will remain conserved. So we can compare the initial and final angular momentum. The final angular momentum is 2I omega and initially it was I omega 1 plus I omega 2, or we can say that omega is equal to omega 1 plus omega 2 divided by 2. Here omega is the final angular velocity. Okay. So now the loss in the energy can be written as initial kinetic energy minus final kinetic energy. The initial kinetic energy for disk 1 can be written as half I omega 1 square. For disk 2 it can be written as half I omega 2 square, and the final kinetic energy will be equal to half multiplied by moment of inertia which is 2I multiplied by the final angular velocity omega 1 plus omega 2 divided by 2 whole square. Okay, if I see here this I and half both will be common, so let's take this as common outside, this will be half I, we will be left with omega 1 square plus omega 2 square. Now we will be having minus 2 into omega 1, let's say this 2 also taken outside, so it will be 4. So omega 1 square plus omega 2 square plus 2 omega 1 omega 2. Okay, and if I solve it, so I will be getting half I into omega 1 square divided by 2 plus omega 2 square divided by 2 minus omega 1 omega 2, which is actually equal to I divided by 4 into omega 1 square plus omega 2 square minus 2 omega 1 omega 2, which is I divided by 4 into omega 1 minus omega 2 whole square, which is our option number